So we are starting with deep learning. So obviously, yesterday you would have discussed about, since it was a day one. So obviously, you would have discussed about what is a deep learning and how artificial intelligence and machine learning are a part of deep learning. So when you take up deep learning, it's actually the subset of machine learning. In the sense, we all know that because this is the basic thing we all learn when we start about. Sorry, when we start about deep learning. Yeah. So when you take up artificial intelligence, it's the revolution started in 1960s, and probably over a period of 50, 60 years, we had different types of evolutions happening under different perspectives, and we reached a saturated point that everything works under artificial intelligence. That is the actual scenarios of now. So as we all are professors, we know that how ADS and AIML is thriving through the engineering students. So the basic thing is AI started with a basic concept of what is modeling, what is agents, what are the environments we have, and that was the under discussion topic actually. And there came a specific area to be noticed, which is called as machine learning. Okay, so what they did is they tried to make, actually the scenario when they started with artificial intelligence, they never thought of recreating a human being. But actually, in the recent newspaper, I mean, I had a LinkedIn post which is actually a part of a newspaper. I thought of sharing it with you, but I forgot to take up. It was all about the artificial intelligence taking over the farming. So it is actually a machine learning, a deep learned robot which is taking care of the entire farming process. So we have to understand how artificial intelligence have evolved so far. And being all the professors, since everyone is professor here, everybody knows how artificial intelligence have been so far, right? So when it started, it had nothing to do with anything as of now, nothing to do with robotics, nothing was there. It was always about the environments, the agents, the what we teach and what is going to be given to us. So this is what was artificial intelligence all about. And in the mid of 1980s, machine learning came into existence. It was like the machine has to understand what we are talking about, and it has to predict the output if the conversation goes out of context, right? So that was the evolution, and there came a topic which is called as machine learning, and that became a subset of artificial intelligence. And over a period of time, after 1900s, and in the sense 1990s, so 1900s, 1990s, in early 1990s, 1992, 93, we had a separate part which is called as deep learning. So basically, deep learning came into existence as a part of machine learning, where, as the name itself suggests, you're going to learn deep, you're going to learn much more than the machine learning part. So it became a subset of machine learning, which uses algorithms, and it's going to mimic the human brain, right? That's what is said here. It is going to stimulate the human brain for decision making. So basically, if you speak about the definition of deep learning, we will say deep learning is a subset of machine learning that uses an algorithms to mimic the human brain to solve the problems or to solve complex tasks. Okay, so what and all are included in deep learning? We can say reinforcement learning. Reinforcement learning is a part of artificial intelligence where you will have multiple agents performing tasks on a competitive environment, and they are rewarded for their behaviors. Excuse me. So they are rewarded for their behaviors, and so you get appreciations, you get depreciations for your work, for your wrongdoings, everything. Yeah, that comes under reinforcement learning. And there is another topic which is called as convolution neural networks. I think this has been discussed yesterday elaborately, but I'll just give a small gist about it. So convolution neural networks, CNN, is actually a popular algorithm which which is used widely in image recognition. Okay, so when you take up image recognition, obviously you will have CNNs. So without CNN, nothing has been there. And the next third important part of deep learning is GANs. It's called Generative Adversarial Networks, GAN, GANs. So GAN is a model that learns to generate realistic data by learning the distribution from real series. You know what is a real series, right? Real samples. So it's like you'll have a real data set with you, and you're going to learn from the real data set, and it will understand the emotions and it emote accordingly whenever the situation arises. So you're going to read everything from the realistic environment, and you're going to do it as such. So that comes under GANs. And there comes the other neural network, which is called as recurrent neural networks, and it is a widest and rapid growing area. I mean, there are n number of researches happening under recurrent neural networks where a model improves its sequence is by adding the history of the inputs. I mean, this actually RNN is actually based on the Markovian principle. What a Markovian principle states? A Markovian principle states your current input is based on your, I mean, sorry, your current outputs, not inputs. Your current output is based on your current input, and it is relied on the past output, right? So taking the base from the Markovian model, your RNN, recurrent neural networks, is a promising area where you can have n number of things to be done here in deep learning. And you have something called as unsupervised learning, which is common among us. Yeah. So, which a normal technique which finds a data, and without being explicitly trained by any algorithms, by nothing is happening there. So it is getting trained without any explicit training. So it's getting trained by itself, without any situations, without any environments. So the data is getting trained by own. That's what unsupervised learning is all about. Unsupervised learning obviously is all about the training which is given explicitly under different types of inputs. Yeah. So this is all about the different types of deep learning we understand. So on the screen, you're finding a question which is called as what is artificial intelligence. So I gave you a small introduction. So here, see the theory and the development of computer systems, which is the ability to perform a task, right? Using the visual perception, using the speech recognition, and also you have to make the decisions, translate between languages, and the applications goes so far. So this is the basic idea of artificial intelligence. And when you take up AI, it is done in many of the areas of specializations. You can take it as gameplay, expert system, robotics, neural networks, natural language processing, anything. Right? So we all play games online, right? You can play Ludos, you can play chess, you can play cards. Everything is done in online. So how is this online gaming possible? It's the use of AI. Obviously, the agents, obviously, the opposite player, which is a machine, should understand your moves. It has to predict what is your move. So, at first, when game playing came into picture, they started with an unsupervised learning. So, what happens is the opposite party who is sitting against you will understand, will get to know what is the player's intention in the first few games. Yeah. So the machine which is playing against you will understand what is your move and which type of moves you're going to take. And then from the third or the fourth play, it will start to understand the pattern of a play, and it will work accordingly. So that is the basic idea when it comes to gameplay. And we all know number plate recognition. We all have fast track with us. Yes, when you cross when you cross a counter, yeah, when you cross a toll, what happens? You your number is being recognized by the machine, and it checks whether the number plate through which the car or the vehicle has been registered is has or had whatever maybe the history, had paid their fast track fees. So, do they have to pay any toll amount here, or are they free to go? So, this is being calculated, this is being rememberized in the number plate recognition techniques. So, basically, the idea is all about learning. So, as we all are human beings, we have to learn throughout the age which we live, right? So the same theme is being applied here for the machines also. The machine has to learn, improvise itself, and then it has to decide. So this is the basic idea here in number plate recognition. And we have something called as Google Assistant, which is Siri in Apple phones, right? So the what happens when you speak with the Siri, or when you speak with the Google Assistant or anything? What happens here, or Gemini, whatever maybe? What happens? Your speech is being recognized by the machine. It is converted into text, and it is being Googled. It's being searched, and the search is being given back to you as the result. So these are all the applications we all know about the artificial intelligence, and I'm just giving you a short recap. So this is what I told you about the AI technologies timeline. It all started with artificial intelligence, where the basic core idea is to make up intelligent machines and programs. That's it, nothing more than that. Okay. From artificial intelligence, see, till the emerging, sorry, the emerging of all the, see, I see, from 1950s till 1980s, you had artificial intelligence playing a key role. Yeah. And it's all about keeping it simple. You have to make intelligent machines and programs. That's it. That's what it's all about. And when after 1980s till 2000s, what happened was machine learning came into picture. So machine learning is all about the ability to learn without being programmed. So artificial intelligence was all about programming. Yes, you give something and you'll get the output, simple. But when you come to machine learning, it's all about something which are which is done without program. You should not do anything programming, but there should be the output. This is what about the machine learning. And after 2000s, what happens was there came something called as deep learning, yeah, which is an advanced topic of machine learning, also a subset of machine learning, right? So what you're going to do is you're going to learn deep into the neural networks. When you talk about machine learning, I think you would have discussed yesterday about neural networks, right? And so you don't know explicitly about something called as neural networks. So can somebody mute, please? Can somebody mute?
क्या हाल है कौन वो आ गया राइट कैबिन
Thank you. Okay. So we were talking about the AI technologies timeline. So there came deep learning, which dive deep into the neural networks, right? So it's all about the hidden layers part where you're going to understand everything. So there is an important end happening here inside deep learning. So neural network is a part of machine learning, obviously. Yeah, without neural networks, without artificial neural networks, ANN or CNN, nothing is possible here. So you have the, just a second, yeah, you have the okay, yeah, you have the privilege to uh, understand or deep dive into the neural network, take up the prediction, take up the sigmoid function, take up the transfer function, make a little bit change, understand what will be the output for a given input. Yeah, so this is how the technologies have evolved. And we know what is machine learning. This is the basic thing we all understand, right? So machine learning is actually a type of AI, yes. So which provides the computer with the ability to learn without explicitly programmed. Okay. So the simple idea is basically you have a machine here. This is the machine. Okay. I've implied it as a robot, and I have an input here, and the input is all about the data set. The data set is being fetched into the machine. Yeah, it's being fetched into the machine. So the machine learned something here. What happens is I have a new input getting inside the machine, and this machine will learn everything about the width, length, whatever may be. Okay, so say for example, what I've given is I've given the data about the flower. It's all about the flower. Yeah. So I have given some data about the length, width, the petal length, petal stretch, and what is the output, everything. So this has been learned by the machine here. And what happens is when I give a new input, this machine has to predict the output. This is the input I have given here, and this is the output. So the output prediction happens, and it identifies among which whatever the data is given, among which inputs, whatever the data I have, what is being trained, and whatever matches with the input. I think it can be exact match or an approximate match, right? So here the exact match or the approximate match will be a sunflower. So this is what happens here. There are two types of algorithms actually. One is exact algorithm, another one is approximation algorithm. Exact algorithm predicts the exact data, and that is what happened with artificial intelligence when we were speaking. When when the AI started its evolution, what happened was everything was programmed, everything was explicitly trained. So there happened to be an exact algorithm. So when you take up the current scenario, what happens here is when you have an approximation algorithm which will train itself, even though you are not giving an explicit program, which will train itself to understand whatever the data is given to you, whatever the input is given to you, and whatever is predicted here. So there comes the prediction of data. And we have something called as limitations of machine learning. So the major limitation we had in machine learning was all about feature extraction. So we had problems with feature extractions. So because of this problem, deep learning came into picture. DL came into picture. So one of the very biggest challenge in the traditional machine learning model was feature extraction. Okay. So whenever I want to recognize an object, okay, or a handwriting or a speech, I mean, it's all about the computer vision, CV. It's all about the speech recognition, SR, and it's all about the text, complex text. Say for example, we have Google Translator nowadays, right? So when you have any languages there on your banner or on your poster, on your paper, on your text, anywhere, if you scan it using Google Lens, it converts into the language which you understand. All right, you can convert it to English, Malayalam, Tamil, whatever's needed. So there was a problem posed when you had a problem with feature extraction, when you had a problem with object recognition, visualization, when you had a problem with the speech recognition. So these were the limitations of machine learning you had, right? So that was the initial problem, and where you found a solution called deep learning, right? So that is the basic idea. And you have a robot. Okay, this is the problem here. You have a robot, and this is the picture we have. And how does the robot recognizes the picture? It recognizes using a pattern. Yes, and this pattern is always not understood by the robot. Basically, it will be like it will have all the zeros and ones with the ASCII code values and everything. There could be a problem in recognition when you have only machine learning. You will never understand the patterns. There could be a problem, a mess up for the machines. So there came the topic deep learning, which is actually a mode. When you take up machine learning, you can convert we have different modes in our cameras, we have different modes in our mobiles, laptops, everywhere. So similarly, when you take up a machine, you have a different mode, which is called deep learning mode. And when you switch on the deep learning mode, it will focus only on the right features. Okay. And it will always require guidance only from the programmer, only a little guidance from the programmer. And you will have the right features to be focused. And only you already have the data which is being trained and the right features focused. From a little guidance from the programmer, you will get the output, exact output. Okay, so there is a problem which is called as dimensionality problem. So the basic idea of dimensionality problem is you have something called as XY axis. So basically, uh, if you take up the 3D model, if it is a 2D model, obviously you will have x and y axis. If you take up 3D model, obviously it will be have you will have x, y, and z axis. So the basic problem here in dimensionality problem is when you are working with the high dimensional data, something like more than 3D, 3 dimensions, you will have a problem with the computational complexity. Obviously, the time complexity and the space complexity increases, and there is a problem with the overfitting. There is a problem with the spurious correlations. So everything happens. Spurious hits is like you will get the output, but that output doesn't feature or doesn't fit with the input you provide. So that's called spurious relations. So overfitting is like you will have the values with you, and the overfitting will be like you uh, under which conditions you need certain things to happen. No, it will like I mean, I'll tell you, you will have two problems, which is overfitting and underfitting. So our both are a concepts of machine learning. Um, and overfitting also and underfitting also will lead to a poor model performance, in the sense um, overfitting. I'll tell you what overfitting is. You will have a training data, but the test data will be poor. Okay, the model will perform very good in the training data. Okay, when you test the data, it will never give you the exact output. In the sense, under given situations, your um, machine performs very well. Okay, but when you give a new input, it will think what is happening here. I'm not able to come to a solution. So that is called overfitting. It's like this happens when usually this overfitting, this happens when a model learns too much detail. I mean, we usually say too much of anything is good for nothing, right? So that's what happens here when your data is trying to learn so much detail. What happens is your training will be perfect. It will give you a very good output. Whereas your testing will be poor, so much of poor, because you will have noises also in the training data. Okay, so overfitting usually occurs in a complex model, and in the sense when you train the data for, I mean, when you overtrain the data, you should not say test train. When you overtrain the data, then obviously the data set becomes too complex. The machine will learn too much detail, and it will never come to solution. Okay, so that's called overfitting. When you take up or talk about underfitting, a model which performs poorly in both the cases. In overfitting, your data performs, your machine performs very good in training. Okay, only the test fails. But when you take up the underfitting model, your your machine fails both in the training and in the testing. So when a model is too simplicity, or if it is very simple, if your model is too simplistic, and it doesn't understand the underlying patterns of the training data, obviously your model becomes classified. Your model doesn't become, it will be classified underfitting data. Okay, so usually underfitting happens when you have a poor set of data, when the data is not completely packed, when it is not completely designed in a certain way. So this is called overfitting and underfitting. So let's come back to the dimensionality problem. So dimensionality problem is like when the dimensions increase, basically we have only two inputs. Okay, that's what we all feel about. When you come to the research works, yeah, you will have more number of dimensions. Yes, so it will be X, Y, Z, and even more. Okay, so whenever you have an improvisation in the dimensionality, when you have more number of dimensions, obviously this leads to the computational complexity. That means the time and the space complexity increases. Obviously, feature selection, feature extraction, and whatever may be the process you're involving in the designing of the machine, everything becomes complex, and that leads to a problem of overfitting and underfitting. Okay, so when you take, this is the basic idea of dimensionality problem. So what happens here is, when you use deep learning, you're partially solving. You have to understand, it's not completely solving, it's partially solving the dimensionality problem. Okay, so the basic idea of deep learning is to build learning algorithms that mimic brains. So this is the basic definition of machine learning. It's like you are just having an algorithm which will mimic the brain. Okay, it's the learning algorithm which is going to mimic the brain. Yeah. So we were just discussing about the common things we all know. I was just highlighting on what and all is required to understand the deep learning concept. So the major aim is to review the concept, the architecture, the algorithms, whatever the trends and the issues, research issues you have in the deep learning process. So the objectives of my session is very clear about the three topics. One is to discuss the concept of deep learning by the definition, architecture, and the basic algorithms. Yes. And the second one is I have related works. Yes. A specific application areas. As I said, I have been working on deep learning because I have my research doing. I mean, my research is so curious, and it always needs deep learning. Okay, so I am learning, I am exploring, I'm working on deep learning for a past 2 to 3 years for my research. So I'll be reviewing all the related works I have gone through so far, and we'll be discussing on that on the second. That's my second objective. And the third objective is going to be what are the research issues we face and what are the trends that is going in deep learning. So these are the three basic objectives for my session. So you know what is a deep learning? We have been discussing about the deep learning so far. So from the picture itself, you'll be able to understand. So this is a part of a brain which has only one half, correct? So what am I trying to do is using deep learning, I'm trying to build the other half of the brain. Okay, like this, the other half of the brain. So what am I doing? I'm trying to utilize this part. Yes, this is your machine learning part, right? So I'm trying to utilize this part and I'm trying to construct the other part. So this is the basic objective of machine learning. I mean, sorry, deep learning. Yeah. So I'm just trying to learn from one part and reconstruct the other part. That is the idea of learning. Okay. So we all know what is a deep learning. So we have a class of machine learning techniques which can exploit any nonlinear information. It is not necessary that all your informations, there's a difference between information and data, right? What is an information? What is a data basically? So data, I mean, how will an information and data will be? Information is all about things you receive, right? And data is all about you organize it in a certain way, right? So whenever your data is raw, whenever your data is unprocessed, and while the information is just all about, mm, it's like you're implying something. Say, for example, I have A, I have B. If I add A and B, I'll get C. So what is A, B, C here? These are all datas. They are unorganized. They are just received, right? So that's that idea of data. And what is an information? It's like if I add A and B, I'll get C. So whenever your data is raw, whenever data is unprocessed facts, whereas the information is always not raw, it's always processed. Yeah, the data is how we all receive it. Yeah, whenever you take up the information, it is always processed, it will be organized in a peculiar way, and it can be interpreted wherever your data cannot be interpreted. When you convert your data to information, you'll be able to interpret it. So that is the basic difference between information and data. So what is the data basically? It's always raw, it remains unprocessed. Whereas we, from the name itself, we can understand, when you take up the information, it is always processed, organized in a peculiar way, and we can take up the interpretations from the information. So what is used here, whether it is a data or an information? Deep learning uses information. Okay, understand please. Deep learning uses information. Just a second. Ah, yeah, fine. Yeah, so deep learning uses information. So, and in the information also, it is not necessary that you have to use all the linear information. It can be a non-linear information also. And also, it is not necessary, it has to be supervised. It can also be unsupervised. Okay, so deep learning is basically a machine learning technique which will exploit all the non-linear information process, and it can also process linear, it's not a problem, but it has non-linear information processing along with supervised, also the unsupervised feature extraction and transformation, along with the pattern classification and analysis, along with the pattern classification and analysis. So what does it do? It takes up the linear and non-linear data. It can take up the supervised and unsupervised data. Yeah, and what you can do, it can extract the features from the data or the information, and it can analyze the pattern and classify it and give you the output. So this is the basic idea of deep learning. When you go deeper, you'll understand. So when you take up deep learning, one major thing you have to remember is deep learning uses deep artificial neural networks. Okay. So when you take up neural networks, obviously you know you will have an input, you will have an output, and there will be a hidden layer, obviously. Yeah. So when you increase the number of hidden layer, obviously there will be the output which is so accurate, which is so exact. Okay, you can avoid approximations. That is the major idea when you have more number of hidden layers. Yes. So this is the basic idea of um, deep learning, and we'll go to the next slide. So obviously, deep learning is a composition of machine learning along with the representation learning. So that is deep learning. You know, deep learning is a subfield of machine learning. Again and again, I'm repeating the same concept. Sorry. So you have several levels of representations, like there is a hierarchy of features, factors, concepts. There is high level of concepts, everything. There will be a hierarchical level, higher order level, lower level, everything is being included. And this is the definition given by Likan, Binko, and Hinton in 2015. Okay. So basically, if you take up deep learning, it's a combination of machine learning and representation learning. What you speak about representation learning is actually a set of methods which allows the machine to feed with raw data. When you speak up about data itself, it is raw. And what will it do? It will automatically discover the representations needed for deduction and classification. This was a definition given by Deng and Yu in 2014. Okay. So when you take up representation, what is that? It is actually a set of methods. So it allows you to fill the raw data, and it will allow you to understand automatically. There is no need to program or anything. It will automatically discover the representation for deduction and classification. Okay, so this is the idea of representation learning. So what is deep learning? Yeah, you can have many number of definitions. It's a subset of machine learning, inside artificial intelligence, has so and so, blah blah blah. But one major thing you have to remember is always about deep learning is a combination of machine learning and representation learning. That's important. I hope this would be a new concept for you whenever, I mean, you would have gone through the deep learning. Um, I mean, some of you would have handled deep learning papers. Some of you would have gone for any other deep learning, FDPs, everything. But this word would be new to is what I believe. When you take up a machine learning, it, along with the representation learning, that constitutes a deep learning technique. So what is happening in deep learning now? So actually, nothing is um, happened. Nothing has happened till 1970s. Okay, so after 1970s, what happened was the paper started publishing in deep learning, and there has been many research big breakthroughs in neural networks, right? So what is done here? What is the outcome of this? You are increasing the computational power and the GPUs. Okay, so everything is being taken. I mean, whatever data I'm talking about is taken from edureka.co. Okay, so I've given reference there. And you have two things to remember always in deep learning. One is vanishing gradient, and the one is gradient descent. Okay, so what is vanishing gradient? Yesterday, you would have understood what is a sigmoid function. Yeah, the basic problem in vanishing gradient was you have a sigmoid type activation function which will saturate at one particular point. Okay, so the gradients would be small, and the deep, and it will be in deeper layer. So the updates will almost will become zero. So this is the basic problem when you take up a vanishing gradient. Okay, so the solution is, earlier it was like you will have to have a training layer by layer. Okay, so that was the basic problem we always had. Okay, and what is the current situation? The current situation is you are having a non-saturating activation function. You don't saturate your activation function. That's the problem. It's like you would have thinking, you might be thinking now, so what is this lady talking about, the vanishing gradient? I'll tell you what is the vanishing gradient. There is something called as vanishing gradient problem, which is a common issue which occurs whenever you train a deep learning neural network. Okay, when you have a deep neural network, there is a problem which is called as vanishing gradient problem. So, what is all about the problem? So, we all have heard about back propagation in machine learning. So, during back propagation, there will be a loss. Okay, there will be an error calculated at the output layer, and calculate. You know how the back propagation is all about. So, there is an output, and obviously, you're calculating the error. Yes, and how was it calculated? It will be propagated back through the network to update the weights. So that's how your back propagation happens. So, however, the gradient can become very small. Okay. However, what happens? The gradient can become very small. And what happens here is whenever your propagation is going through the back propagation procedure, your gradient will have a loss at a minimum loss, and this keeps on happening and happening again and again. And in the initial layers, it may be light, yeah. You would have had more number of hidden layers. So whenever you propagate the gradient, whenever you propagate the loss error, what happens is the gradient becomes too small. At the initial layer, it may be light, but when you go deeper into the layers, the gradient value becomes zero. Okay, so what happens is this will slow down the process, slow down the learning process, and it will actually, you can say that this will stop the learning process basically. That is the biggest problem. So you understand, I hope you understood what is a gradient, vanishing gradient problem. It's like, I'll repeat it once again. You have a back propagation. You know how the back propagation happens. You have an error, and the error will be propagated from the output, right? Output layer, it will be propagated back, one, two, three, four. What happens in propagation, what happens when you're propagating back is almost reaching from one back propagation layer to the other. In the initial layers, it may be light. When you reach at a certain point of the hidden layer, what happens is your back propagation value becomes zero. So what happens when a back propagation value becomes zero? This will stop the learning, or the this will slow down the learning process. That's the major problem. Okay, so this is actually the vanishing gradient problem, and uh, the earlier times in 1970s, we had to have layer by layer pre-training. That was a solution. And now what we have done is we have a ReLU layer activation function, ReLU activation function. So using this ReLU activation function, we can eradicate, okay, we can eradicate the vanishing gradient problem. Okay, so you know what is ReLU, I think. So it's called rectified linear unit. It's called ReLU, rectified linear unit. So this is actually a nonlinear activation function. Okay, so this using ReLU activation function, you can eradicate what vanishing gradient problem. And also there is another solution for this. This is like, you can have residual connections. So the output of each layer will be added to the output of the subsequent layers. That's called residual layer corrections. So you can do like that. So there are two solutions for this. And now we always go with ReLU. So that is what is said as non-saturating activation function. This is ReLU. Okay, so ReLU is like rectified linear unit. This is the first major issues that is being sorted out in deep learning. And the second problem is gradient descent. Okay, so we all know what is gradient descent. Yes. What happens here is you have a first order method, that's called SGD. Yeah. So which are easily stuck. So you have second order methods, which will be feasible also, right? And if you have larger data, you know what is SGD, right? Stochastic gradient descent. That's called SGD. So when you speak about first order methods, obviously SGD stochastic gradient method comes into picture. That becomes easily stuck. Yeah. When you speak about the second order methods that are feasible in the larger data, but what happens is you won't get the accuracy for the output. So that is a major problem in gradient descent. So one of the commonly and you the name gradient descent always suggests that this is one of the commonly used optimization techniques in machine learning. That is the major idea. So even if you have gradient descent in your machine, you have a problem with dealing the methods, first order methods and the second order methods, right? So what should we do? Even though we don't have the descent method here, uh, what can be the better output for you? Even if I have the gradient descent method in my machine, what could be the better output? Yeah. Why am I concerned about this gradient descent is first order methods always provides the optimized solution. That is stochastic gradient descent provides always the optimized solution. Whereas the second order methods are feasible, but will it provide an optimized data? That seems to be a question. This was the problem in the early stage of deep learning. So now, what is the solution for it? We have adapted training, which is called ADAGRAD, ADAM, ADA Delta, RPS Probe, and Nistro Momentum. These are all the adapted training mechanisms we have now. Okay. And there is something called as regularizations. Basically, this is just all about if you say things can overfit to your network sometimes. So what you can do here is, I mean, there was a problem basically in the early stages of deep learning. And what you can do here is you can drop out all the overfitting network problems, all the overfitting data in the network. So that is the only solution we have still now here in deep learning. This is the major breakthroughs. This is the major research breakthroughs we have all in our deep learning. Just a second. Yeah, all in our deep learning techniques. Fine. So how deep learning will work? Let's understand the working of deep learning. So basically, what if you speak about deep learning, as I said earlier, deep learning are a part of neural networks. So basically, the motivation is all about the neurons. We all know the stuffs, right? Because when we start with the neural networks, the very first thing is about the neurons. We'll have a structure of the neurons, synapses, everything, right? Conductors, everything. Yeah. So we all know that. So basically, deep learning, two things to remember. One is deep learning is achieved through neural networks. The second one is the basic idea behind the neural networks is biological neuron. Okay. So how I'll tell you how the deep learning will work. Deep learning, as I said, is a part of artificial intelligence, which will use what? Neural networks to teach the computers to learn from the data. Okay, that's a basic idea. And it will recognize the pattern and it will make the decisions. It will recognize what pattern is being communicated, or on what pattern the data has been communicated to me, and it will learn to make decisions. So you have the first part is going to be the neural networks. So deep learning will use what? Artificial neural networks. It's called ANN. Okay, artificial neural networks. And you know, ANN will always be made up of layers with interconnected nodes, and each nodes learns to have a special feature of a data, everything like that, all the stuffs in the neural networks. Yeah. Yes. The second part is going to be the training part. Okay. So this is always about the biological neuron, dendrite, cell body, axons, synapses, whatever. You know all these stuffs. I don't want to revise it again. So I'm modeling this to a neural network, something like this. This is a schematic representation of a neuron in a neural net. Okay. So what happens here is after you create what a neuron is all about, you're going to just train the data. how training is happening, you will have the weights, obviously, the connections between the nodes and the transfer function. There will be a connection between the nodes and the transfer function, and you have a weight associated to it, right? So this weights are adjusted to classify better, and this is called training, and you know that, right? The next part is called prediction. Prediction is like once you train everything, what will happen? The neural network can be used to make predictions with the new data. When you give a new data, it will try to predict the output. And we know what is the data and what is an information, right? So obviously, you have different types of data to produce different types of outputs. You have large number of sets, so and so, all the things, all the stuffs. The second major thing you have to remember about this training and testing and deep learning is all about the architecture. So there are different types of deep learning architecture, each tailored for a specific task. For example, you have CNN, we have, I mean, yeah, I heard that CNN has been discussed yesterday. So when you talk about convolution neural network, CNN, which are good at image processing, okay? And I hope I'll try to cover the RNN, which is, as I said earlier, recurrent neural networks is actually a promising area of research now. So recurrent neural networks are good in handling sequential data. Whenever the data is sequential, RNN is very good in translating, right? So these are all the things, I mean, the basic structure of deep learning, how it works. So yeah. So what are the unique characteristics of deep learning? Why is it used? Deep learning uses feature extraction. Yes, whenever you have high dimensional data for training, you can use deep learning. Whenever you have high level of features and you have to define it from a low level features, and if there is a use of the previous layer, as I said, it depends on Markovian model. MKM, it's called Markovian model. Yes, so you can use deep learning. And whenever there is a deep learning, as I said earlier, all the other things, if you would have heard, deep learning is a part of AI, it's a part of machine learning, everything. But this word would be new for you, which is called representation learning, right? We have discussed representation learning earlier. So whenever you want to represent something, obviously you can use deep learning. And yeah, deep learning can solve any real world or any unconstrained problems in NLP, image recognition, etc. So these are the basic characteristics of deep learning. And as researchers, we all thrive into different types of tools for us to get the output, correct? So these are the some of the softwares, but I have taken up only a few, but it's not limited to here. You can have a number of softwares. So you have TensorFlow, Piano, Torch is, will be similar to you, something called as PyTorch, right? Keras, Blocks, Cafe2, MXNet, Mat Convolution Networks, MatConNet, it's called Mat Convolution Networks, Microsoft Cognitive Toolkit, Deep Learning 4J, VLab, everything. So I basically use Keras, okay, TensorFlow, PyTorch, Mat Convolution Neural Network, and DLab for my data and for my images. This is what I use. I have used all these tools, not more than that. So this is not limited to this much people. It is, you have a number of tools, but I have listed only few, whatever is known to me. Okay. And the next is categories of deep architecture with algorithms. So one is supervised or discriminated deep learning. This will be a new term for you. I hope so, because you have heard about supervised learning. Supervised learning is also called as discriminative deep learning. That's a new word, I think so. And the second type of deep learning architecture is unsupervised learning. Again, there is another name for this. It's called generative deep learning. Yes. And there is something called as hybrid deep learning architecture, which is a combination of supervised and unsupervised architectures. So this is a CNN architecture. You have discussed this yesterday. So supervised or discriminative deep learning, which consists of convolution neural networks, CNNs. Okay. So CNN is one of the most notable deep learning approaches where you have multiple layers trained in a robust manner. Okay, so this is the definition given by Lacan and Boto in their paper 1998. Okay, so see, you have a convolutional layer and a pooling layer. You have an image. There is a convoluted layer. There is a pooling layer, which is given inside a fully connected layer. Obviously, there is an input, hidden layers, everything. And what happens is the images are getting classified. Yeah, it's like, is it a dog? Is it a person? Is it a cat? Anything, right? So I have taken the picture from the pipeline of general CNN architecture from Goa et al. In 2016. So I hope you're clear with convolution neural network. So basically, I'll come up with a small definition of convolution neural network. So if you take up a CNN, a convolution neural network, it's a type of artificial neural network which uses multiple layers to filter or to learn the features, okay, of the data to make the predictions. So CNNs in deep learning network are often used for what? Image recognition. So whenever you speak about CNN, convolution neural network, obviously it is used for image recognition and processing. Okay, so and it's like it's not like you have to use only for image recognition. You can use it for speech recognition. You can use it for text, audio, time series, anything. But what happens here is when you use it for image recognition, it would be easier and it would be like very good. You could, I mean, your convolution neural network works in a better way when you go for image recognition. That's what I try to convey. Okay, so we you have discussed all this yesterday itself, I hope so. So how a face is being recognized, so it's like it will take up the different features constructed together to form a face. So that this is the basic idea of CNN. And the next topic is all about the unsupervised or generative deep learning. Okay, so what do you know about generative deep learning? I hope this would be a new thing for you. You would have heard about unsupervised learning. More or less, unsupervised learning is what is generative deep learning. And there is something called as generative AI now, right? We all have come, we all are coming across this common term which is called as generative AI. Have you ever thought what generative AI is all about? Generative AI is about uh, I mean, as the name itself suggests, you're just trying to generate something. Okay. So a type of AI which is trying to create a new content. Name itself is giving you a word, generative AI. So you're trying to generate something, right? A new content or new idea, right? Like text, images, videos, music, audio, whatever mean. Okay, you're going to get a generated data in the sense you're going to try to make new things. Okay, so generative AI deeply relies on generative deep learning. Okay, so generative deep learning is basically about, I mean, the deep learning technique basically relies on unsupervised learning. So that is the basic thing you have to remember. So you understood the connection, right? So there is something called as generative AI, which is generating something. Yeah. So you're going to try with new ideas, new things. Yeah. So generative AI is relying on what? Generative deep learning. And the idea of generative deep learning is relying on what? Unsupervised learning, obviously. And inside this generative deep learning, you have something called as RBM, which is restricted Boltzmann machines. Okay. I hope you would have heard this, restricted Boltzmann machines. So RBM is basically a type of artificial neural network. It's actually ANN. Whatever you speak inside a deep learning technique is all about neural networks. Yes. So whenever you speak about deep learning, obviously there will be um, neural network which is coming into picture. So RBM is again a type of artificial neural network which is learning its probability distribution over its input. Okay, so it's trying to learn the probability distribution over the input. Okay, so obviously, the major pictorial representation or the major architecture representation of, sorry, RBM is, it is stochastic. Yes, and it is always a two-layered neural network. So this is the basic idea. And if you speak about stochastic, what is stochastic? Stochastic is actually a probability distribution or a pattern which can be analyzed statistically. Okay, that's called stochastic. If I say, if stochastic gradient descent, what does it mean? You are just analyzing it in a form of a you're just analyzing it in statistical basics. Okay, so it's like the on the probable the basis of probability distribution, or you're going to analyzing the statistic, or you're going to analyze the pattern statistically. Okay, and you can predict it easily. That's the one thing you have to remember, and that is the word stochastic means here in deep learning. Okay, so when you speak about RBM is always an artificial neural networks. It's ANN, with what probability distribution over networks, that you have to remember. And the architectural diagram of the RBM is always a two-layered neural network, yeah, which can automatically detect the pattern by sending or reconstructing the input. So what is it? It is a two-layered pattern. Yeah, it's a two-layered pattern which can automatically detect the patterns. Yeah, it's a two-layered structure which can automatically detect the pattern either by sending the input or by reconstructing the input. Okay, so this is the basic diagram I have borrowed from a paper written by Goa in 2016. So these are the different variants of um, restricted Boltzmann missions. Okay, so just a second. Okay, yeah, sorry, I got a message. Yeah, so we have three types of, it's not three types, you can have six, I think you have 6 or 7 types of RBMs. Okay, I have discussed about DBN here, which is convolutional neural networks. Okay, and you can a deep neural network which is created by the combination of RBM along with convolutional neural network. Okay, that's called DBN networks. Yeah, and I've discussed one more RBM here, which is DBM. DBM is actually DBM is actually deep Boltzmann machines. So again, it is constructed using stacking deep RBMs together. It is constructed using what? Stacking RBMs together. When you speak about DBN is always a combination of CNN, convolution neural networks, along with RBM. So that becomes DBN. The second one is DBM, which is deep Boltzmann machines. Okay. Okay. So if you speak about DBN, what is DBN, people? It is deep belief network. Okay. DBN is deep belief network, DBN. Okay. So what is that? It is a combination of CNN and what? What? RBN. Okay. It's a combination of DBN is a combination of what? Deep belief networks is a combination of neural networks, I mean CNNs and RBN. If you take up DBM is deep Boltzmann machine, DBM. What you're going to do is you're stacking all the RBMs together to form DBM, and you have something called as DEM. What could be DEM? It's called deep engineered missions, DEM. Okay, so DEM is always a combination of generative AIs, in the sense deep learning networks, generative AIs, along with the convolution neural networks with the implementation of RBM. So DEM is actually deep engineered machines, DEM, or you can say it as deep. Just a second. Yeah, sorry, I'm getting distracted. Sorry, yeah. So DEM is actually, you can say it as deep engineered missions, or you can say it as deep energy models, or you can say it as digital elevated models. You can say it in three ways, okay? Digital elevated models, or deep energy missions, or um, a deep deep elevated models once, deep energy missions, yeah, and deep engineered missions. So you can say it in three ways: engineered, energy, and elevated models. So you can say it in three ways. So basically DEMs are, I work with DEM basically, because I work with a spatial data which has more number of dimensions. Okay, so when you have three or more dimensions of data, you can go and work with the DEMs. And obviously, if you take up DBM or DBN, it's always about, if you take up DBN, belief network, it is always about the text classifications. Okay, when you take up about DBM is Boltzmann machine, which is deep. You can go with the voice recognition techniques. Okay, when you take up DBM, belief networks, is always about the text.
Excuse me, ma'am.
Yeah,
Excuse me, ma'am. Slide is not moving, ma'am. Slide is not changing.
I am speaking about the variance only, actually.
Okay. Okay,
But
ma'am.
this is the,
If it is
I mean,
shown in slide, it will be more helpful for us to understand.
okay, sure. So when you speak about, where were we? Yeah. So when you speak about DBN, which is always a belief network, belief network always speaks about text. Okay, sorry, it always speaks about text. And when you take about DBM, it's always recognizes speech. Okay, and if you speak about DEM, which is always spatial, it all, I use DEM for spatial data. Okay, so DEM is always about um, digital elevation models. I mean, deep elevation models or digital elevation models. That's one way of representing. You can say it as energetic models or engineered models. Okay, so when you go for more dimension of data, you can use DEMs. Okay, so when you take up in my case, I have three-dimensional model. Okay, in my research, I have three-dimensional model. I'm taking, my research is all about the space and the earth. So I have to take up the earth's terrain. I have to elevate the points, plot it. So everything is done using DEM. So whenever you speak about the navigations, we all know navigations, what maps, Google Maps, and we can say about the gyroscopes, right? All uses DEMs. It's called digital elevation models, or digitally deep engineered models, or deep engineered models, or deep energetic models, DEMs. Okay, so whenever you speak about all the gyroscopes, all the navigation procedures, and whenever you want to go deeper into the earth, you if you want to map the soil erosions, all the civil engineered things, whatever the apparatus you have, everything includes, or everything is mapped or trained using DMs. And you have something called as autoencoder. Okay, this is another important part of deep learning, which is always AEs. We all have heard about this autoencoders. So autoencoder is actually, the name itself suggests, um, when you speak about deep learning, we have autoencoders and de-encoders. and there is something called as generative encoders, so many things. But here, what am I going to do is I'm going to speak about autoencoders for the basics. Okay, when you take up generative encoders, de-encoders, these all comes under the advanced topics. So when you start with the autoencoder, I'll come to the picture later. Let me talk about what is an autoencoder. Whenever you take up a deep learning, obviously there will be a neural network. This is the basic thing. There is an interconnection of the systems. This is also the basic thing. And what are you going to do? You're going to try to mimic the human brain, basically. So neural networks excel at discerning intricate patterns at the representation with vast data sets. Okay, so when you try to allow predictions or classify the information with a generative insight, there comes the autoencoder. Okay, so you will have a subset of neural networks, yes, and it will allow you to understand the patterns in an unsupervised pattern. Okay, you'll have an autoencoder which is a set of neural networks which will allow you to understand the patterns in an unsupervised fashion, right? So when you speak about more number of autoencoders, I mean, whenever you take up a deep learning machine, there will be a sequence of, I mean, some 500 or 600 number of autoencoder neural networks inside whenever you take up a very complex machine. So I have in my research work, I have almost 101 autoencoders, 101 or 102 autoencoders for classifying my images. So it needs, I mean, also if I speak about huge number of autoencoders, obviously there is a need of huge number of GPUs that you have to remember. So autoencoders are adaptable and strong class of architectures that you have to remember for the dynamic area of deep learning, where the neural networks will casually develop, or it has a constant complicated network pattern. So for learning constant complicated patterns, you always need auto encoders. So whenever there is an effective representation of data, unsupervised model has nothing to do. Okay, there is an effective representation of data. Whenever there is not an effective representation of data, obviously autoencoders come into picture. They'll try to read up the patterns. Okay, so autoencoders are specialized class of algorithms that can learn efficient represents of the input data without labels. But whenever there is there is an inefficient data, okay, if it is an efficient data, autoencoders have least things to play, least role to play. Whenever you have an inefficient data, autoencoders gives you an efficient way of understanding the pattern, understanding the representation, reconstructing the representations. Yes, so that is what autoencoders basically do. So you understand, I hope you understood. Autoencoders are neural networking patterns. Yeah. It's also a specialized class of algorithms which will work efficiently if you have an efficient data. But even if you have an inefficient data also, autoencoder tries to learn everything in an unsupervised fashion, and it will try to reconstruct the inefficient data to an efficient data. All right. This is the basic idea of autoencoders. And let me talk about the picture which is shown to you. You have an input here. There's an encoder here. The encoder will code it out. Yes. What the encoder does here is it will try to find what are the inefficiencies present here. Okay. Inefficiencies present here. And what it does is it will try to encode it and give a very efficient data. And there is a decoder. Okay, uh, the decoder will try to reconstruct the inefficient data again. Already it is encoded. Yes, the inefficient data is already being passed, but even then the auto decoder will try to again reconstruct the data. I mean, your deep data pre-processing, to say it locally, you can say it as a deep data pre-processing that is done here, and you're getting the reconstructed data out. That is what your autoencoder does. And what you'll do is you'll compare the reconstructed data with the input. If you compare the reconstructed data with the input, obviously there will be an error. Why? The input will be in an inefficient way, right? What you have done is you have efficiently reconstructed the data. So when you compare both together, what will happen? There will be an error for sure. So this is the basic idea of auto encoders. And now, what and all have we discussed? We have learned, I mean, there is learning algorithms for the first time. We have learned representation learning. And I said, what is overfitting, underfitting, right? And what are the optimization methods? And I told you about the variance and all, right? So what are we going to do is, I think I've covered all the 5 topics, right? So I'm going to give you a review, a theoretical review of all the 5 topics. Okay, the learning algorithms, presentation learning, all the overfitting techniques, optimization techniques, everything. Okay, so actually this presentation is a part of my PhD work. So how the first part, okay, learning algorithms. I spoke about the learning algorithms. You're going to see about the learning algorithms here. So I had a this is the first one, topic about the learning algorithms, and this is the table which will give you a categorization of what and all the neural network algorithms you have and what all the related approaches. I've taken it from this paper, Goa paper, in 2016, published in 2016. Okay, when you take up CNN, there is something called as AlexaNet. Okay, there is something called as Clarify. There is something called as SPP. I think this will be new to you. I think so. Okay. So the next one is SPP. SPP is called spatial pyramid pooling. Okay, spatial pyramid pooling. That's a part of convolution neural network. I told you CNN is basically good in image processing. So when you take up the image processing, obviously you will have satellite images. Yes. So whenever you have a satellite images, obviously it has to be reconstructed. You cannot just go in and interpret whatever is there in your spatial image, I mean, in your satellite image. So what you have to do is you have to reconstruct it. For that, you're using SPP, which is called as spatial pyramid pooling. Okay, it's spatial spatial pyramid pooling. Spatial pyramid pooling. This is one method. The next one is always about VGG, which stands for Visual Geometry Group. Okay, Visual Geometry Group. Visual Geometry Group. Okay. And one more thing you have is Google Lanet, which is used in all the Google searches. Okay. So that is actually deep learning network used by the Google for its searching technology. I mean, Google Lens widely rely on Google Lanet. Okay. So these are the CNN networks, and each, if you want to learn about each networks, I mean, we have a time constraint. It's almost 12:30, and I hope we have to complete it faster. So I cannot explain all these techniques one by one. So I can just give you a gist of what is what. So if you want to learn more about these networks, you can just refer these papers. Okay, yeah. So when you come to RBM, you have something called as deep belief network. We just discussed this DBN, DBM, DEM. Yes, deep energy models. We discussed about this, right? Deep Boltzmann machines, deep belief net. Yes, we spoke about this. These are all the learning algorithms we have, and I spoke about autoencoder, right? There's something called as sparse autoencoder, denoising autoencoder, and contractive autoencoder. What sparse autoencoder does is, whenever you have sparse matrices is usually associated with the images. Okay, so whenever you have an images to be reconstructed, you will always use sparse autoencoder. Whenever there is a presence of so much noise in an image or in a text or in a speech, you will always go for denoising autoencoder. And you have a contractive autoencoder, which is majorly used to analyze the images. Okay, say for example, you can go for biopsy reports and all, right? There will be you're just you're just comparing two images to come up with a solution, whether you have the cancer or not, whether something like that. Okay, so if you want to compare two images, if you want to come up with certain solutions on medical theorems and all, you always go with contractive autoencoder to come up with the solutions. Okay, and there is something called as sparse coding. Okay, so this is a special type of learning algorithm which is least used. Okay, sparse coding is never used, and it's never used. Okay, so if you speak about sparse coding, it is least used anywhere. So just a second. Yeah. Okay. So sparse coding is one of the unsupervised methods, and you will have, I mean, you may ask me, where is sparse coding used? Basically, sparse coding is a part of neural networks, and it if you want to, I mean, if there is a complex data, okay, let me put it in this way. If you have a complex data and if you want to represent it in a very simple way, okay, you want to represent a very simple mathematical representation, you will go for sparse coding. So now what happened is, with the emerging trend in deep learning, all the complex data have been utilized, have been interpreted, have been mm, I mean, it's easy for any deep learning machines to understand any number of complex data. So what happened is, over a period of times, the usage of sparse coding diminished off, because once sparse coding was, see, if you see the year itself, you'll understand. In 2009, 2010, and all, they spoke about sparse coding. Why? Because by the time they wanted to represent the complex data in a very simple way, right? They want to represent, so they used sparse coding, and it's a powerful tool also. Okay, but what happened is, with the emerging trend, there had been a very evolution in learning technologies in deep learning. So the usage of sparse coding diminished actually. So that is why I told you sparse coding is least used. So the second part is representation learning. Yeah, I told you what is a representation learning. So what is the representation learning? You want to represent something in a certain way. So you will be using representation learning, right? So it's like a machine learning process to understand the meaningful patterns that is present in the data, yeah, in the raw data, and to make the presentations easier for the machines to process. That is the basic idea of representation learning. So when you focus on the research part, okay, there is a paper by Hitten, Salakutdinov, and Vincent in different years, 2006, 9, and 10, 11. So you have to discover a fast and more efficient way of initializing weight for effective learning of low dimensional codes from high dimensional data, right? For in a multi-layer neural network, that is the important part, right? I told you that deep learning and allows you to learn or gives you the high dimensional data, which is learned from what? Low dimensional data, right? So for that, you have to have, I mean, you have to have the more important, or you have to present it in an efficient way. So that is why representation learning is important. And what are the contribution done here in the papers, or what is the current trend? You're implementing novel learning methods with initializing weight that allows deep AE networks, also deep Boltzmann machines for higher representations. So you're trying to implement the AE networks. What is AE networks basically? AE networks is auto encoders, right? So if you have AE networks, which is being uh, connected in deep, and also if you use Boltzmann machines in deep, you will be able to get high dimensional data from a low dimensional codes. Yeah. So this is the first major part you can focus. And another part to explore the possibility of allowing hash learning function. You all have known what is hashing, right? Those people who have taken up cryptography uh, and cybersecurity will know what hashing is all about. So if you take up a hash learning function, so obviously there is a use or there is a need for binary codes, and you need original data space, and you need feature learning to occur. Everything should happen simultaneously. There will be a hash function first. There will be binary code representation. There will be feature learning. Everything should happen in parallel. So what you can do is you can use deep hashing technique, or you can use supervised deep hashing or semantic hashing. Okay, this is done for image retrieval and text mining. This is what is the contribution as of now. And the third research focus can be on the success of convolutional neural network with, I mean, you have supervised learning and there is an unsupervised learning, right? So you have to bridge a gap between supervised and unsupervised learning using CNNs. Yeah, and that is being done. Yeah, that is being done using a new network form which is called as deep convolutional generative adversarial networks. It's called GANs. Okay, there is something called as transformers, people. I think I didn't discuss it over here. It's an advanced uh, DL topic. So I primarily focused on the prime basics, on the basic deep learning techniques. So when you talk about transformers, adversarial networks plays a very important role. Okay, so when you take up I mean the basic idea of this part is you have to bridge the gap between supervised and unsupervised learning and using CNNs. And what is done here, the CNNs have been constructed in a new format which is called as deep convolutional general adversarial networks, right? GANs, it's called DC GANs. And this bridges the gap between supervised and unsupervised learning. And third one is overfitting technique. You know what is an overfitting and what is an underfitting. I told you that, right? So overfitting performs good in training and it performs least in testing, right? So if you have a sparse data set, yeah, and you have an overfitting in large neural networks, so what you can do is you can use the techniques of dropout. You can use it stochastic pooling. I told you what is stochastic also, right? You can decay the weight, or you can use flipped image augmentation to ensure the stability in DNA, deep neural networks. Okay, so this is one method. Another, the research focus could be on how to investigate the rank source in, I mean, if it is a reinforcement learning, obviously you'll be providing ranks, correct? So in CNN, how to do transfer learning and improve the sum product in a network. Okay, see, so these are all the basic key terms when you learn CNNs. I hope this has been discussed in yesterday's session. These are the key terms we used in CNNs, right? So how can we improvise this? How can we improvise transfer learning? How can we improvise some product network? This is what is the research focus. And what is the current situation is we I mean, the current trend is we have defined a framework, right, which performs zero shot ranking, in the sense if you don't get work done, if it is not done correctly, you'll be providing the value as zero. And if it is done exactly, the ranges may vary with the applications. Yeah, say for example, I'm providing 10 as the highest value. I'll provide 10 for as the ranking if the that particular work, that particular activity has been done correctly. So if the activity is not correct, if it is not done correctly, I will provide zero, right? So it's called zero shot ranking. Okay, that is being done in CNNs for what? Transfer learning. And using transfer learning, I'm implementing what? Some product networks. So what are the optimization methods I have? See, we have already discussed here, right? See, we have Adam, Adagrad, RM, Sprop, Momentum, LG, BFS, Kalman based stochastic gradient. These are all the techniques we have now. Okay, so these are the optimization techniques. Okay, these are all these topics. Okay, all this Adam, Adagrad, everything comes under the advanced topics of deep learning. And also, if you take up how energy consumption is it, you're going to focus more on the energy configurable accelerator for deep neural networks. Okay, so you'll keep skipping and gating. Skipping in the sense, if the data is not valid, if you can't train anything, you'll skip it off. If the data is valid, if it is done, if it is doing good, you will gate it off. That is skipping and gating. Okay, so these are the optimization techniques we have used. Okay, and what are the deep learning variants? See, we have two classification, heterogeneous supervised classification techniques, which is support vector machines and CNNs for feature extraction and classification. That is the major techniques we currently use for what? Feature extraction and classification. What is used for feature extraction? CNN is used for feature extraction. And what is used for classification? We use SVMs for classifications. Yes. And when you have a non-linear features, what will you use? You will use K nearest neighbor algorithm, KNN classification. Variants we always use. Okay. Now we are skipping into, and I think I'm a little bit faster because we have to complete the session in another 20-25 minutes. So I'm just going a little bit faster. So what are the application of literature review? So basically I've concentrated on two things. One is the methodology of applying deep learning. And the second one is the application of deep learning. So one is like deep learning is applied in real life problems. Some of them are. Okay. So basically this is the author. We all know, right? This is the typical representation of literature review. And the basic objective of this author is to improve the sentiment analysis of social applications. Okay. So you have to take up the feature-based approaches. Yeah. Without using manual feature, you have to take up the feature-based approach, and you have to improve the performance of the sentiment analysis for the social applications. Okay. So what they did is they embedded a model of linear machine learning algorithm with the deep learning sentimental classifier, which is baseline. Okay, they embedded these two together to form a classifier which is called as SEM. Okay, and what they did is they named the classifier as SEM. Okay, and they tried to extract the features of gradients and of gradient assistant, MSG and MGA. So using this features, using this variants, they tried to create they try to create a machine which will extract the features automatically without we giving the data manually. That's the basic idea. Okay. So the classifier is named as SIM. And what are the algorithms used here? Linear machine learning algorithm and deep based sentiment classifier, that is called baseline, is used here. Okay, so what happens here is when with the development of this, the sentimental analysis is very good now using the baseline classifier. And the second one is all about the recommendation system. We know what is a recommendation system. We are basically living with the recommendation system, right? When you try to Google something, what happens when you open the Flipkart, when you open the Hotstar, when you open Prime, when you open Flipkart, everything, there will be the solution for that, right? So that's called recommendation system. So what I have to do is I have to improvise. I mean, the basic objective is to distinguish between the recommendation techniques, and you have to identify what deep learning is doing here. Okay, what deep learning is doing here for the content-based techniques. So what are we doing is we are trying to implement a regression technique here. Okay, so you're trying to add a regression inside the methodology. No, it's like already there are recommendation techniques. So sometimes recommend, at some situations, what we do is we'll never go deeper into one particular topic. We just have a random search. We just leave it off, right? But what happens if the a mission takes up it? What happens if the Google takes up seriously, and if it is trying to give you more number of same recommendations, which will irritate you, correct? So to avoid those things, what is done here is they are adding regression to the existing system along with the Bayesian stack denoising autoencoder, which is called as SDA. It's called stack denoising autoencoder. There are different types of encoder. So we just saw what is an encoder, that's it. But I mean, as I said, due to the time limitations, we are not discuss each and every deep learning techniques in detail. So I hope I'm happy that I'm at least able to introduce you to the new terminologies. So you have something called as Bayesian stack denoising autoencoder, and you're adding that with the regression technique so that you'll get up a mission where the deep learning technique is used to find whether the recommendation is actually valid or not. Okay, so that is the methodologies used here. And also, again, there is something called as credit scoring. This is also a real-time application we have, right? So what are we doing here? We are trying to implement some DBN model for carrying out credit scoring apps. Okay, so what are we doing is we are just trying to implement all the DBN techniques, MLR, MLP, say, along with the support vector machines, and we're trying to implement that with along again Boltzmann machine with a tenfold cross validation. That's important. Okay, so you're using one fold cross validation will have a huge data. Okay, it's like you're having tenfold cross validation in the sense it has different types of combinations. The data set is huge, actually it's a huge data, big data. Okay, so you're trying to implement all this and you're going to get up an accurate credit scoring mission. So again, you have something called as another methodology which is being under research for data, I mean deep learning is for plant identification. Okay, using morphological patterns, you have to identify the plant, you whether the plant is this or that. I told you, I mean, at the start of the session, I showed you an example where you're giving the input and the input goes to the sunflower, the output goes to the sunflower. The given set of input matches with the sunflower. So you have to identify the plant using the pattern given to you, right? So for that, we are just obviously you'll use CNN. Okay. And the important part is you're going to use 6 layers trained with stochastic gradient method. That's important. Okay. And along with a training of 20 samples with 50%, only 50% dropout of regularization is what you're going to do. And using this, you're going to identify the plant. Okay. Along and this is something called as behavior modeling in deep learning. So how am I going to use behavior modeling? Obviously, you'll be using RNN along with the TensorFlow. Okay, behavior modeling, and there is long short term memory. Yeah, it's called LSTM cells. It's also used here for predicting the behavior of a person to predict the behavior of a machine to predict the behavior of the entire if it is a mechanical system, say for example fusion and fission systems will be huge, so you should have the prediction system there. What will happen in the next step if you don't provide the solvent, if you don't provide the cooling air, what will happen? So you have to have the prediction system. So those prediction systems are done using, obviously it will be done using RNN and LSTM cells. Okay, again, emergency alert system, these are all the basic things we would have been discussing so far. So it will be like you will have a CCTV, right? You're going to analyze, there will be an API, application programming interface, and there will be again it's an image. So what we use, you will use convolution neural network for object deduction and parsing. right? So these are the basic methodologies that has been evolving, and that is under the research of deep learning. And some domain applications of deep learning, for a recommendation system, we use sentimental analysis or opinion mining. Okay, and you can refer this particular paper for that. And if your research is on social applications, again, you're using sentimental analysis along with opinion mining with facial recognition. You can refer this paper. Yeah, it's very good, really. And if it is a medical diagnosis, say for example, if it is a medicine, there's a survey paper which contains so many images, and they are taken up as cancer, breast cancer, lung cancer, different types of cancers have been identified there, and X-rays, so many things. So you could refer this paper. And if it is like credit scoring, stock market prediction, anything related to finance, and again, there is a paper, a literature survey paper, which has so many references for you to say which paper implements what and what is currently under the uh, research. So again, if it is a transportation, I mean, if you're going to have a traffic flow prediction, there is a paper with deep learning with short-term traffic flow prediction, and this paper is what is implemented in Google Maps. Okay, so if you read this paper, you'll be able to understand what type of navigation systems they are using. When you check up the Google Map, you can find if there is a traffic at one particular place, it will stop, it will show high traffic, and you need this much amount of time to cross this particular place. So for that, and for process predictions in business, again, there is a deep learning procedure. And emergency alert, again, that comes here in recommendation systems. Yeah. And if you take up agriculture, something like plant identification using morphological patterns, that also we have people. These are all the domain applications of deep learning and the current research processes. And what are the applications of deep learning? Obviously, so we have many applications. So one is automatic machine translation. You know that using Google Translate, how you are going to classify the objects in the photograph, character text generations, and coloring black and white images into colors, and gameplay. You all play with the game, right? So these are all the amazing applications of deep learning. So see, as I told you, right? Google Lens, yeah. It's a set. What does a Google Lens do basically? It is a set of vision-based computing capability which allow your smartphone to identify where the photo is being posted, whether it is a video, whether it is in a live feed, whatever. Yeah. So if you, the simple example is when you focus it on a flower, the Google Lens will tell you which type of flower is this, right? And if you aim it on a peculiar place or a restaurant, you will see the reviews, and whatever the information you want related to that will be shown to you. And the another application of deep learning is translation, which I told you, right? You will have this. There will be a situation where the given words will be in some language, so you have to know that in English. What will happen if you focus that? I mean, if you take up the word, you can say mark is actually dark. Yes, actually dark chocolate, Excel cookies. That's it. So translation, Google Translation is also one such example. And it can be also an image. Okay, so you can focus on the image and ask the Google or whatever the deep learning machine to translate. The translated form of English representation will be given to you in an as an image itself. So that's also an example of image recognition. And this is instant visual translation, Google Translate, the biggest example. There is some representation in a peculiar language. If you scan it, what happens? Getting translated, access to city. And what happens if something is there in English, another language people wants to know it? So what happens if you try to score it? It will show. Yeah, this is what is said. And one important thing which is under construction is self-driving cars. So you have self-driving cars, it needs satellite imaging in the sense it has to focus on the navigation, it has to focus on the traffic, yeah, it has to focus on the ways, and it has to reach the particular place. Yes, so it needs much care, and it needs so much of data. The data is actually huge for creating a self-driving cars. So self-driving cars, actually it has been introduced back in 2018, but still it is not as successful. It needs more number of training, it needs more number of situations to be understood. So still the self-driven cars is being under construction for creating more accurate, safe journey. Yeah, so self-driving cars is under research actually, and this is automatic machine translation. So we all know these type of apps. We use this in our day-to-day activities, right? We have WhatsApp where you can type in your own language, whether it be Tamil or English or Malayalam, Hindi, whatever. You can do it, and if you want to by adding some add-on applications to it, right? So you're adding your whatever language you're putting it there, you're asking it to translate, it's giving it as what is your name. So this is how the machine translation happens. So say for example, I want to put it cooking teacher, I have to translate to Spanish, it comes up, right? So these are all the examples of deep learning techniques. So what are all the trends in deep learning research? I have posted it here. So the basic thing you have to one basic trend which is on research is designing a powerful deep learning model to learn from fewer training data, because we are making the data to learn deep, in the sense your data is learning from huge data set, right? So one area which you can focus is always about from a fewer data, how you can create a powerful model. That is first major research which is going on. Another one is like usage of optimization, optimization algorithms for regularization techniques, something like that. Okay, example for different types of network parameters. Okay, you can take it as overfitting, underfitting, networking situations, regularization situations, whatever may be. So you're going to create an optimized algorithm for network parameters. For example, regularization. Yes, this is another important place where deep learning needs. It's under the research is under progress. Okay, and implementation of deep learning algorithm on mobile devices. This is almost done, but still we are able to reconstruct our photos using our mobile devices, right? We have reached till there. So still there are things which could be explored. And how to analyze the stability in a deep neural network. This is another area of interest which is under research. And what you can do is you can try to combine probabilistic autoencoder and manifold learning models. This is one new method, a combination of different types of models together, and you can rename it as a new one. So this is one thing. And you can apply applications of deep neural networks in a non-linear networked control systems. Usually the control systems will be linear. What happens if you have a non-linear networked control systems? So how deep neural network can be applied there? That is another place where the current trend is going on. And the next one is applying unsupervised, semi-supervised, and reinforcement learning approaches together. Okay, it's not separate, together in one place, which is what deep neural networks for complex systems. Yeah, so you're going to combine all. It will be a hybrid approach, right? Supervised, semi-supervised, and reinforcement learning is always a hybrid approach. So you can create a hybrid approach. So this is another place where the research is going on. And there is something called as learning deep networks for machine learning techniques. It's called deep KNN. Yeah, this is also under research. So you're creating a social neural network, deep KNN. So I'll complete within 2 minutes. Yeah, I know it's time. I'll complete within 2 minutes. So What are the challenges you face in deep learning is the cost. Whenever you try to build a model, obviously there will be involvement of huge number of GPUs, and you have to load it. There will be you need more time, you need more cost to implement a deep learning model. So high computational cost is always an it's always a part of deep learning. That's one problem. The second problem is overfitting problem. Whenever your data is small, yeah, and when you have to fix up the local minima, that when you use the first order method, obviously if you use the stochastic gradient method and all, you have to fix the local minima. So that is the basic optimization issue you always have. And if you don't understand the theoretical foundation of a deep learning architecture, then it will be hard for you to implement a deep learning architecture, deep learning method. Obviously, again, if you have a space complexity, you will always have time complexity in deep learning. So these are the basic problems you always face. Okay. So I have a use case here. Yeah. So the basic use case is the problem scenario. We want to create a system which will recognize faces of different people in an image. How do we solve this as a typical machine learning algorithm or using a deep learning approach? So what I will do is we will define the facial features. Basically, if you take up a machine learning approach, what will you do? You'll define the facial features such as eyes, nose, ears, etc. So what happens is the system will then identify the features, yes, and it will identify whether it is a person by itself, or it will just say it is a person. That's it, right? It depends on the data you give. If you're giving the face of a person, it will say this is the person, or it will say that it is a person. It is either of the way. The simple idea is you will give the facial features like eyes, ears, nose, etc. So what happens when you use a deep learning approach is going to take it one step ahead. Okay. And what will you do is deep learning will automatically find its features. Okay. Using classification technique, it will automatically, this is important, it will automatically identify its features. Whereas in machine learning, what you have to do? You have to do it manually. You have to define all the features manually, and then you have to come up with a solution. But in deep learning, what happens? You're training the data. So obviously, your data will automatically understand the features. These are all the features. If these are all the features present, obviously this is going to be a person, or this is the person. This is the person's photo, and this is the person. It will provide you that. Yeah. So for a facial recognition, what happens is you will have an input layer. You will have a number of pictures as an input. Yes. In the input layer, what happens is the constraints are being classified in the network itself. And what happens is the constraints have been defined in the network input layer. The hidden layer one classifies the features. Okay, these are all the features that has been that has been used to identify whether it is a person or not. What will happen after identifying the face features? The feature will be sent to the hidden layer 2, where the face is reconstructed. Yeah, and you're getting the output. Finally, this is the face of so and so, or this is the face of a person. You'll get it as the output. So this is the basic idea of face recognition using deep networks. So you have two phases for a face recognition. The first phase is like you have a sample for faces. The faces are deducted, features are extracted, and obviously you are keeping that in a database. Okay, and what you're going to do is you have a query face, the face to be matched. The face is deducted and pre-processed, features are extracted, and you have the data from here, and the extracted features are being matched. Finally, you're getting the result. Okay, so this is how the architecture is. So what happens here is you're defining that into two phases, phase one and phase two. In the first phase, you have a model system which trains, and you have the query system which finds. This is trains and this is finds. That's it. These are the two basic idea. So this is what we have seen in the architecture. So it's like enrollment phase is like you're going to put the histogram of gradients inside your algorithm. Yeah, you're deducting the faces for features. And what happens is you'll use, obviously, if it is an image, obviously you'll go for deep convolution neural network, DCNN, to learn the important features. Yeah, features are extracted. Yes, and it is put inside the database, feature database. Obviously, inside the recognition phase, you are recognizing whether the person is present or whether it is the face of a person. Yeah. So when you take up the pre-processing, what will happen? It will try to recognize the face, the pose, the 3D transformations. Everything will be marked. Okay, like top of the chin, outside the edge of the eye, outside the edge of the nose, mouth, eyebrows. Everything will be marked, and then you will have 128 feature values inside DCCAN. So obviously, once the query image is received, the feature values inside the DCCN are matched. Yes, and from the database, and the recognition is done using SVM classifier, Bayesian classifier, or distance classifier. Euclidean distance classifier. It depends on which type of classifier you're going to use. The most common used classifier is SVM classifier. Okay, and finally the output is given as the recognition value. So finally, when I wind up this session, deep learning is actually a learning method. You can, like, if you say something is artificially intelligent, obviously there will be a huge hands for deep learning. So without deep learning, nothing is possible for an artificial intelligence. That is the importance. That is how the deep learning is as of now. So when you try to build an architecture, you have to learn, the first basic thing is you have to learn all the basic algorithms. And as a researcher point of view, what I could say is you can incorporate n number of basic algorithms together to form one big algorithm, so that it will be a hybrid approach. Yes, and there are huge research areas where in deep learning where there are only theoretical concepts. There is no practical application, or there is no practical representation. So this is one place you can go research it, do it. Yeah. So, and one thing, you can, I mean, as a researcher point of view, what I can say is you can build hybrid algorithms. This is one thing. Second thing is, there are n number of places of complex real world data, which needs manual features engineering. So where you can just go implement deep learning techniques, make things easier. These are two places where you can go with the research proposals. Yeah. So, and one thing, when I speak about deep learning, always artificial intelligence. When you speak about artificial intelligence, there will be always deep learning. Without deep learning, nothing is possible in the current world. And obviously, if you go for deep learning, the resources for hardware, the computational technologies, whatever applications you're using, it needs the time complexity. Whenever you speak about deep learning, obviously time complexities and space complexities plays a very good role. And these are the references I used. Finally, I'm winding up my session. So thank you very much for listening. And I have to acknowledge the efforts of Pencil Bits, the coordinators who coordinated the session, and especially Sangeeta Madam, who gave me the opportunity to share the knowledge about deep learning, which is my research area. So thank you everyone for listening. And uh, if anything, you can just contact me if you want to just have a query, or if you have any doubts regarding deep learning techniques, you can just reach me out. And if there is any questions also, I'm feel free to ask. um,
What
Uh,
type of deep learning technique will be suitable for medical image processing, ma'am?
Medical image processing, you can go with convolution neural network, ma'am. CNN is very good, really.
Okay.
CNN is very good, and recurrent neural networks are also they are trying. I mean, as of now, even myself, I'm trying to implement RNN in spatial data. Okay, so RNN with along with the CNN is under research now. So basic thing you can go with CNN is a very good option, or if you can try to build a hybrid algorithm with RNN along with the CNN. Yeah.
Okay, ma'am. Okay, ma'am. How we can design the hidden layers for our application?
Okay. Uh,
Hidden.
Ma'am, if you are trying to build a hidden layer, obviously you have to identify the features. I mean, in which, say, for example, if I'm doing an niche classification, obviously I should have the features with me. So without having the features, I cannot design. I mean, the thing is, with which you are identifying your data. Simple. If I'm having these are the features, these are the things that has to identify this particular data. I have to identify that. That's called features here. So I have to identify the features. Using the features, I have to create the nodes, hidden layer nodes, like input nodes. I have to create the hidden layer nodes along with, and it depends on which type of network you're using, neural networks. If it is a Boltzmann machine, obviously you should have transfer function. Obviously, you should have gradient function, and which level of order function you're going to use. These all play an important role when you're going to build a hidden layer map. So it basically depends on the type of the neural network you're going to implement, and what is the type of the data you have, and what are the features you have to extract. And along with the, if you choose this particular network you're going to use, you have to implement all the activation functions, transfer learning, what and all is related to that. You have to implement that in hidden layer map.
Okay, ma'am. Thank you, ma'am.
Thank you, ma'am. Thank you, Pencil Bits India. Yeah.
Thank you, ma'am. Thank you for spending a valuable time. It was a very great session, ma'am. Thank you all.
Yeah.
Shall we
Thank you.
finish, ma'am?
Thank you so much. Thank you so much.
Okay, thank you all. You can end the session. Certificate will be received by 3 business working days.